Wonderful AP students. We're going to do the day 66 homework for you to make sure you understand what's going on. So please get your homework ready. Let's go to the first one right over here. In this one, there's two resistors along with a third. Now this is inside the battery. It's called terminal resistance. It's just pretty much a separate resistor. It's asking you how these three things compare. Well, please draw a current arrow with me. Starting here, I'm going to use a different color. There's no splits or junctions, so the current is one big loop, which means it's a series. And since it's a series circuit like this, that means all these currents are going to be equal, which is letter D. Again, they're equal because it doesn't split up anywhere. So the current leaving the battery is the same through each one. All right, let's go on to number two. Number two, this one's a little more complicated, so we're going to go through the ideas here. So we have a circuit. And notice how it says 3 volts, and we have 100 and 100 and 100 in here, which is totally right. I'm going to draw the current arrows like I taught you to do. The current starts off, it goes, it's a fun time. And at this point, it splits up into two different parts. There's this path and this path. Since these both resistances are the same, that means we'll have equal flows. They're going to have half the total. So what it's asking for, it's saying the potential difference is 3 volts. That's how much voltage there is. It's asking to compare the voltage on this one when this one's in and out of the circuit. So let's take this and make it look simple. These two are 100 and 100. When two things are in parallel, that means the resistance is cut in half. So it's equivalent to drawing 150 with 3 volts. Okay, so these two are in series, which means they're going to have the same flow with different volts. The voltage is going to split up. Will it split up in half? No way. This one's going to have more voltage than this one because it has more resistance. You can think of this as a system of 150 ohms. This has 2/3 of the total resistance, so let's have 2/3 of the voltage. So its voltage will be 2/3 of the total, which is 2 volts, and this will be 1 volt. And since in parallel they have the same voltage, each of these will be 1 volt, and this will be 2 volts. Cool. But now we take this one out. It's dead, it's gone, it's like my respect for people. Not true. So at this point, this one's gone. These two are now one after another, turns them into series. So now my new picture is them in series like that, 100 and 100. Is the voltage still going to be 3? Of course. Is it still split up 2 and 1? No, because these are now both equal. So they're going to share half of the voltage. It'll be 1.5 and 1.5. Therefore, this one's voltage went down 1.5. This one's jumped up 0.5. And that is the correct answer. It should be letter C. Welcome to question number 3. Now this one's a little bit math one. It asks you for the current through the 3 ohm resistor, this thing right here. So here's what I'm going to do. I'm going to first figure out the total current in the system. And then I'm going to see how that relates to these two things. In order to figure out the total current, I need to find the total resistance. 3 and 6, okay, those are in parallel. So I'm going to do some quick math. 1 over 3 plus 1 over 6 equals 1 over REQ. I know these two are in parallel because the current starts at 12, goes through the 10, and at this point it splits up. And here it recombines. So these two paths are parallel to each other. 1/3 plus 1/6, you combine them up. And I'm going to get 3/6 equals REQ, which gives me a resistance of 2. So now I'm going to redraw this. There's a 1 ohm, and then these two combine into 2 ohms. So now these two are in series. These two combined is in series with the 1. That's a total resistance of 3. And from V equals IR, the voltage is 12, the resistance is 3. I can find the total current is 4 amps. So I found my total current. But the question is how much goes through this? Okay, 4 amps goes through this one right here. So this is all 4. Then it splits. Does it split equally? You're right, Hannah, it is not. Which one will have more flow, the 3 or the 6? The 3, because there's less resistance. Now here's what I taught you to think. The 3 and the 6, it's like you can think of it as a system of 9. This has 1/3 of the resistance, so it'll receive 2/3 of the flow. Again, 3 and 6 together, you can think of it as like a total of 9, even though 9 isn't like in the system. This has 1/3 the resistance of the system, will have 2/3 of the flow. 2/3 of 4 is 8/3, which is 2.66 amps. And that is the answer, letter B. But let's just make sure. What if I wasn't too comfortable with that? Well, here's what I do. This is 1 ohm, it's got 4 amps through it. 4 times 1 gives me 4 volts from V equals IR. V, I, R. The 1 ohm, R1, R2, R3, total. I'm writing really small for some stupid ass reason. One, 3, 6, I'm sorry. We found the total to be 3. The current I found to be total of 4. 4 goes through all of it, so V equals IR, you got 4 volts here, the total is 12. So there's now 8 volts remaining. And remember, in parallel they both have the same voltage, so both things will have 8 volts. This is 12 volts right here, 12, 12, it drops down by 4. This is 8, 8, 8, jumps down to 0, 0, so these have voltage of 8 volts. Do the math for this current. 8 over 3, that's what I had, 2.66. Let's go on to the last one. Welcome back to question number 4. Look at these two different systems here. These have the same resistance, and there's a light bulb as well. It's asking for true statements. Now, looking at this, I want to see how these two light bulbs compare. First of all, I know they're going to be different. Because look at this system. These two are in series, so they combine to get 2R resistance. But these two are in parallel. When two things are in parallel and equal, the resistance is half, so it's half R. So this system has got way more resistance than this system. And since they have the same voltage, this is going to have way less current than this bottom one. So which statements are correct? A, these are the same brightness because the resistance is the same. No way, they're hooked up differently. So A is false, because based on this hookup, it has too much resistance, so little flow, which is little brightness. B, bulb B is a greater voltage drop than bulb A. Ooh, let's take a look at that. Bulb B is a greater voltage drop. Well, each of these have a voltage drop because they're in series. This is another voltage drop. All three must equal the total. But here, this has less of a voltage drop because it has less resistance than these two. These two are like 2R, this is like half R. More resistance equals more voltage drop. This has a huge voltage drop, this is a tiny voltage drop. So then this must have a little bit to add to the total, this has a large bit. So actually, B has got a greater voltage drop than A, is correct. But we're not done because there's one more answer. C, the currents through each bulb are the same as the currents through the batteries. Let's find out. This is the battery current. Oh, that's the same, because it has the same path. Here, it splits up, but only for these resistors. The battery and the bulb have the same current, so that's correct. And as proof, letter D is A has more current than B. Nope. B's got more than A. And it's time for the last one. Time for number 5. Look at this complex looking mofo right here. That looks ugly. Now it says that there are 4 resistors and 4 ammeters. What the heck's an ammeter? That's something that measures current. It's like the amps part of your multimeter. So this thing right here just measures the current through it. So this would measure I. Whereas the top one measures I1, this one measures I2. And this is back to being I. So these two should always read the same amount. Which of the following must be true about the current through 2 and 3? 2 and 3. Well, they're in series. These should have the same current. Okay? But then it says the current through ammeter A1 is 6. So this has got 6 amps. And this has got 2 amps. Oh, if 6 go in and 2 go in the top, how many should go through the bottom? That's right, Hannah. It's 4. So we're going to eliminate C and D. Now, why is it that they have the same current? It's because they're in series with each other, not because of the same voltage drop. In fact, these could have different voltage drop if they're different resistances. But even if they have the same resistance, they must, or different resistance, they must have the same flow. Then for number 2, if this resistor is given, what else is needed to get the voltage of the battery? Well, I know this current. What else do I need? Well, I know this amps. So with that amps, I can figure out the amps down here. And based on the 2 to 4 proportion, I can figure out some other stuff as well. So now we're going to figure out about what we need to figure out what is going on. That was a horrible sentence. I'm just editing right now. Anyway, we're going to figure out, if we're given R4, what information do we need to find the voltage? Well, I know R4 now. I know the current is 6. So I know how much voltage is used here. I can figure out the voltage used here. But these two have the same voltage because they're in parallel. So all I need is this current, which I have, and this resistance. So all I need is C, R1. So I know this resistance and this current, I can figure out the voltage for this, which is the same as voltage for this. And I can add that voltage to this voltage over here, which I know because I know R and I. That's it. Thanks and have a great day.